So thank you for the introduction. My name is Jake DeBow. Obviously, I'm a graduate student here at the University of Vermont. I'm going to talk a little bit about my thesis research, which is part of a larger collaboration between Vermont Fish and Wildlife Department, University of Vermont, and Vermont Cooperative Fish and Wildlife Research Unit. As I'm sure most people in this room know, moose are declining in New England. They're also declining across the majority of this. Oh, that should be a little bit lower, but across the majority of the southern portion of their range. This is due to a variety of different climatic factors, the majority of which have to do with parasites moving northward into historic moose range. Mainly winter tick, which you see here on your right, and P. tenuis, also known as brainworm, which you see on the left. Now, the story of moose in Vermont is not unlike that of other New England states. We saw a large peak in the late 1990s into early 2000s, which was a response to large-scale forestry and a reduction or a lack of harvest and little to no predators. The state of Vermont responded to this by increasing harvest to try and reduce the population to a level that they felt was within their cultural and ecological carrying capacity. The state was successful in this right around 2010. Unfortunately, that's about when these parasites began to really show an impact in the population. So this further decline in this trend is not intended. So where are we studying moose? We are conducting our research project out of northeastern Vermont. Wildlife Management Units E1 and E2. This is really the heart of moose country. Just over 1,700 square kilometers. It's more than enough land to keep us busy chasing collared moose. So in 2017 and 2018, we radio collared moose with a capture crew that does this work for Maine, New Hampshire, Vermont, and New York. So they're really good at what they do. They've handled hundreds and hundreds of moose with an extremely low myopathy rate. They're able to catch these moose, put a radio collar on them that has a VHF and GPS beacon, attach ear tags, and take a suite of biological samples, releasing the animal in under 10 to 15 minutes. Very impressive. So in 2017, to get the project started, we collared 30 cows and 30 calves. In 2018, in order to replenish the calf age class, we collared another 30 calves, as well as an additional 6 cows to kind of bolster our productivity work. So I'm going to talk a little bit about my 2 chapters tonight. Chapter 1 is dealing with survival estimates, and what is the most important part about survival? Figuring out why things are dying. So when these collars are still for 5 hours or more, you get a mortality email and a text message. These things notoriously come in Friday nights, Saturday mornings, or right when you have something really important to do. But we respond as quickly as we can. We usually get these animals within 8 to 12 hours. We perform a full field necropsy, where we take a sample from every major organ and every major tissue and send it out to pathology. Moving to objectives 2 and 3, this is where we're starting to model some of these things, and we will be using a known fates modeling approach. This allows us to stagger the entry of individuals into our study over the duration of the project, as well as censor individuals as some may drop their collars or collars may shut off. And we'll be analyzing 2 main covariate types. These are going to be annual and individual covariates. So annual covariates are things that affect the population as a whole, year, snow depth, and so forth. Whereas individual covariates are things that affect that specific animal, things like age, sex, or percent cover within their habitat. So what have we seen so far? Here we have adult and calf survival rates for 2017 and 2018. Overall, we've seen 93% survival of the adult age class. This is good. This is to be expected. This is right around where we thought that we would see. The calf survival, as you can see here, is low. It's low, but it's not as low as what's been seen in some neighboring populations. It's something to be concerned about, but it's also something that we feel that we can build off of is looking up. So what do we anticipate to see moving forward? We think we're going to see an overall reduction of survival in all age classes, but that survival will be observed greatest in the calf age class, as they just don't have the size, the body size, to sustain the number of ticks that they're getting on them. We also think that fall weather conditions are going to have the greatest impact on tick levels and thus affect survival the greatest, and predation and anthropogenic factors we feel will not have a large effect on survival. Moving into chapter 2. chapter 2 has to do with fecundity and productivity of moose. So, what's the most important part about that? Figuring out who is pregnant. When we're capturing moose and we actually have these adults in hand, we can take blood, spin the blood, and send serum off for analysis for pregnancy tests. It's pretty simple. We get a test back, pregnant, not pregnant. But unfortunately, we only get this for the 1 year that we capture them. But during that year, it's very important because it allows us to focus our resources during while we're pursuing objective 2, which is estimating fecundity rates. Now, this is the bulk of our field work. This is when we are in the field following these animals with those VHF beacons, getting as closely as we can to these cows, observing the presence or absence of a calf, and removing ourselves from their area without being seen. It takes a lot of resources, a lot of time. With 30 cows on landscape, you can imagine it's quite a bit of work. But it's really important because it's allowing us to see some of these fine scale variables like exact birth dates, birth habitats, death dates. Sometimes we're in there at just the right amount, at just the right time, we can actually get our hands on deceased neonate and assign a cause of death. Moving into the estimation of that, we'll be using a linear regression to estimate fecundity and a nest survival model of the Kaplan-Meier survival curve to estimate neonate survival. So what have we seen here? On top, we have birth rates, and down low, we have neonate survival. Right off the bat, from 2017 to 2018, we've seen an increase in both of these numbers. That's very exciting, that's good, everyone's happy. But it's important to remember, in 2017, this was the first year all of these adults were in our study. So by 2018, those animals that may have been 2 or 3 and may have been first-time breeders, not as successful, are now experienced breeders and are in a position to have a better chance of getting an offspring to the next age class. And we've seen 68% for both birth rates and neonate survival. This is just below the North American average of 84%. Again, we're comparing to what we've seen in some of the neighboring states like New Hampshire and Maine. They're doing similar studies where they've had very, very low productivity rates. So we feel like this is something that we can begin to build a population off of, is looking up. So what do we expect to see? We do expect to see an overall reduction in these parameters from a healthy population. We think that as dam health begins to decrease, that's going to be passed on to the offspring. You'll have neonates that are being born smaller and thus more vulnerable to mortality. We think that things like twinning and yearling ovulation are going to be reduced or absent altogether, as those are the first things that you see in a healthy population. They're also the first things that go in a not healthy population. And we think that models including age and successive breeding will fulfill that. So, why do we care? Why is this important? As we begin to manage these animals that are at the peripheral of their ranges, we're going to have to change the way that we look at the rates that we know so far. We've been studying these animals for decades and decades. We have a pretty good understanding of what their productivity and mortality rates are, but we don't know what that looks like in the face of a changing climate. And so as we begin to move forward, like many species that are on the edges of the range, we need to get a really good understanding of this so we can manage them to sustain in the future as long as possible. And with that, I'd like to thank all the funders, all the different organizations that are involved in this, and a suite of individuals who have really helped to make this project what it is. Questions? Right there. Raise your hands high. We have seen some dispersal, but not as much as you think. Out of 97 animals that we've collared, we've only had 2 that have made major movements over highways. We had 1 go all the way to Gray, Maine, and another that went over to Sugarbush, I believe. Nice, stack it. All right. No, so these are, and that is a very good question, these are winter ticks. So, and this is a 6-inch ruler just for some scale for everybody. So this is an ungulate-specific tick. It's made its living on deer historically. So it kind of travels north with deer and has been able to sustain now that it has shorter winters. The winters are more favorable for their life cycles. But this is, while this tick would get on us, the life cycle is so long. It's a single host species. So it would have to be on you for months and months and months and months and months. And because we shower, we don't maintain these ticks on us.
How many ticks on average?
Yeah. So we have done some tick counts only on calves. So mind you, these are 9-month-old calves, right around 350 pounds live weight. And we personally have counted upwards of 50,000 ticks on one moose. But in neighboring states, they counted upwards of 98,000. So pushing 100,000 ticks on an animal this big. Yeah, it's a good question. This is definitely the heart of moose country, and it's definitely, the densities there are the reason that we're seeing these tick issues. Ticks are a density-dependent animal, so the more hosts on the landscape, the more ticks that there will be. Moose densities vary throughout the state. In areas that have lower densities, the tick issue isn't as much of an issue because there's just not enough moose to sustain those numbers of ticks that it takes to kill the calf age class. In those areas, though, we see brainworm having more of an effect on the moose population as you have higher deer densities in those areas, and those two things are related.
What would you like to see for a captivity survivor?
Oh man, that is a great question. I mean, I think everyone would like to see 100%, but realistically, in the face of ticks, I mean, if we could have that survival rate up around 70%, and granted, this isn't often sound literature, don't hold me to that, this is just kind of me thinking here, I would think that we'd be able to really start to build a population again. As long as we're above 50%, we'll continue to move in that upward trend. But yeah, I mean, the higher the better.
All right, so you want to move between sections? We're welcome to do that.
Thank you so much, Jake.